Hi, I'm Jishan Chen. Today I'm talking about BN321 Assignment 2 demonstration. I'm going to share my screen now. So we have to do a network implementation for our senior and elderly side, and the system require a stable, a reliable, and highly available network architecture, and possible and easy to maintenance. So we can use the questionnaire for us, our user, like the how many they use per day, how many user they use the network per day, and how much the data will be user be uploading and downloading each day, and what kind of the software and the application user will be running over the network, and bandwidth informations and application sites. What are the instance requirements required for applications? Is like the bandwidth, backup, reliability, cloud computing, which one they are more focused about it, and do the user require any access to remote application like permission? If yes, and provide more detail for us. Thank you. And which one and what kind of the application the user prefer to use to do the online work? Is like Microsoft Office, Open Office, or other different application software, and they can give us the detail. And like network, we have to know how many device, route, switch, and DCs, such will be used in the network, and do the network need any variants for separated department, yes or no? And do they need a VPN configuration in case the work from home, and sometimes they might not able to go to the physical office, or they bring their work at home. And do they need have our resource sharing, like the database file, document servers, or the printer? They can share in their documentation for the different people from the different departments and different sites as well. And for the device side, I put like the business requirement, device configuration, quantity development, allocations, and we can see the multiple switch for the senior and automated side, and the switch name and normal switch for the different 5 departments, and router and the firewall support VPN and VLANs. And according to the device implementation, decide do the user have any advice or different, feedback for us, and they can leave their information details here. And for the company side, we have to ask, do they agree our network design? And they can take out the question, and or they have the different feedback, or they probably are satisfied, and they can give us the feedback as well. So thank you for that, and we go for the next one.
My name is Rajwendra Kaur. My student ID is MIT 2208669, and I'm going to discuss about the devices and technical aspects of this assignment. To design and implement an IT infrastructure between two different sites, you first need to understand the technical aspects and requirements through the selection of relevant hardware and which network technology to pursue as needed. The two different networks must be bridged across the internet via virtual private network or other form of IP tunnel that encapsulates packets, including their headers containing the private addresses. For transmission across a public network, a wide area network is a computer network that spans large geographic areas such as countries and even intercontinental distances. WANs often use transmission equipment provided by common network operators. WAN technology typically operates at the bottom 3 layers of the OSI reference model: the physical layer, the data link layer, and the network layer. A private corporate network is a network that a single organization builds to connect office locations. The WAN is a computer network that spans regions, countries, and even the world from a communication protocol and conceptual standpoint. The WAN may best thought of as a computer network technology used to send data over long distances and across different networks using network devices. This difference is because common local area network technologies such as Ethernet and Wi-Fi formats that run below the OSI model are often designed for physically closed networks. WANs are used to select network switches, routers, and hubs to connect LANs and other types of networks, allowing users and computers in one location to communicate with users and computer in other locations. Many WANs are created by your organization and are private. The other is that the router connects one lane to the second router in the other. LAN network protocols include TCP, IP, provide transport and addressing capabilities. Protocols such as packet over SDH, multi-protocol label switching, transfer mode, and FAME relay are commonly used by service providers to provide the connection used in the WAN. Routers and switches are general-purpose devices that connect two or more heterogeneous networks. These are typically intended for special-purpose computers with separate input and output network interface for each connector network. There are core distribution access and compact switches to extend the network performance of your corporate LAN. These switches platforms differ from fanless switches with 8 fixed ports.
My name is Sisi Powder and my student ID is MIT 221464. Today I'm going to talk about the requirements of the devices we are using in our assignment. So the devices used are routers, switches, VLAN, and security devices. To start with switches, we are using a normal switch that is S3C S300 160 PSI. As a consequence of these, the access layer will indeed be able to accommodate the optoelectronic devices, multiplexing gigabit uplinks, as well as mixed stacking. Some of the features are that dimension-wise, it is 40 centimeters long, 30 centimeters wide, and weighs around 3.2 kg. It has got 24 fixed ports, one management port with the console support, and the power AC is supported to be 100 volts. The multi-layer switch we are using is S3C S5500 200 SCSI, which fits our proposed network. The switch incorporates full gigabit layer 3 core. Some of the features are that it is 40 centimeters lengthwise and its width is 30 centimeters. It weighs around 4.5 kg. It has got one management port. The input voltage is AC wise 100 volts to 240 at 50 hertz. Next one is router. So the platform, the router we are using is S3C MSR21X with a throughput rate of 160 kbps. It even has a RAM of 256 MB, which is quite remarkable for a router. Additional characteristics are compatibility for GFE switch module, video, and encryption modules. Some of the features of the routers are that it has got one SiC slot port, one RJ45 auto sensing one port. The processor used is RISC at 333 megahertz. The memory is 246 MB DDSR RAM with 32 MB flash. It is 40 centimeters long and 30 centimeters wide. The voltage is 100 volts to 220 volts AC. The power rating is 25 watts and the frequency is either 50 or 60 hertz. For the VLAN, we are using a Telecom 10 fiber connections, which is visually checked on the cable, and a spiral jack construction safeguards the ubiquitous model optical fiber against the short circuits. On the security side, we are using Norton's antivirus. It has got packet screening at the protocol, and it is supported, by the way. It gives a compelling threat, prevents a role to play in helping safeguard devices against existing and emerging internet dangers, as well as protecting personal and financial information that are after the cyber. A password manager is a program which is generated through this antivirus, and it allows you to securely generate, record, and manage passwords, credit card information, and other credentials online. PC firewall, that is smart control CPU connectivity and assist in blocking of unwanted traffic as well. It has got 2 GB of cloud memory backup storage. And with that, I'm back to the speakers. Thank you.
Hi, my name is Anis Mainali, MIT 192308. Today I'm here to demonstrate BN321 network design for the purpose of assignment 2. So let me share my screen for Cisco Packet Tracer, and I'll be explaining more in detail. So as you can see in the diagram, we have two branches, one in Adelaide and one in Sydney. So both the branches are connected through the routers. So we have created a wide area network between those routers, and each of the routers is connected to a multi-layer switch in each branches. Here the multi-layer switch is going to act as a backbone for the whole network, and further these multi-layer switch is connected to individual switches in each departments. So using a VLSM technique, we have assigned the IP addresses to each departments, as similar in the Sydney branch as well. So according to the VLSM, so the IP addresses, the network ID is divided for all these 5 departments. And since if there is no any configuration in the switches, then all the department can see the information from each other's department, and also there will be a traffic congestion. So in order to avoid that issue, we'll be assigning VLAN to each department. As you can see in the figure, there is VLAN 10 for sales department, VLAN 20 for customer service, VLAN 30 for finance, VLAN 40 for marketing, VLAN 50 for management departments. So in this way, we'll be doing our network design. So in the switch, we'll be configuring the VLAN for all these departments, and also we'll be assigning the IP addresses to each VLAN, and also we'll be configuring the DHCP pool in the VLAN, switch itself. So doing that, we don't need to individually assign IP addresses to each devices or each host in each department. So doing configuring DHCP will help us to assign IP addresses dynamically. So this is all about our network design. So far the design looks good and it's working perfectly. Thank you for watching.